Hi, today we are going to start a new topic, the money time value. This is a concept used a lot in many areas, accounting, finance, management, any type of project that involves future cash flows and to consider, and also some cost involved in implementing that particular project. And but the money time value as a concept is important to understand because let's say you have $100 bill. Okay, today you can buy less with this $100 bill than how much you could have bought 50 years ago, right? Why? Because since then there was so much inflation added to purchasing power, to goods and services. At the same time, $100 bill right now is worth more than it's going to be worth 50 years from now. 50 years from now, you're going to buy less with this $100 bill. So that's the concept really. When you go into the future, you grow your money. Future value of any amount is going to grow going into the future because you add some level of interest. You invest that amount of money at some interest and you make more money, and the compounding process is inside these calculations. On the other hand, when you calculate the present value of any value, it's going to be diminished because the present value, as I explained earlier, is going to be less because you take out inflation, you discount for that level of inflation. So the present value of any amount is going to go down. So we are going to use this concept when we discuss about time value associated with money, when we discuss future values first, going into the future, added interest, compounding process with the interest rates, and then we calculate present value. What's the present value of some amount to be received in the future? So then we are going to discuss different level of returns corresponding to different projects, different scenarios, and compounding as an instrument and is included in these calculations. Relationship to the capital outlay decisions. When you consider, you have to do some calculations before deciding to invest in, let's say, buying a piece of equipment, machinery that will increase your production levels and your cash flows in the future. Before you make that decision, you have to do a cost-benefit analysis. You have to consider all the future benefits, the sum of future cash flows when considering money time values and the interest rate incorporated into future valuations. And also you have to consider all the cost adjusted for inflation. So those are the calculations that we are going to look into next. And as a note, businesses really, they use software to incorporate these calculations for future values, present values. They have specific software, but you have to give them the initial data like the interest rate levels for compounding, number of years you want to do the compounding, and then they do the calculations for you. So we are going to start with future value one amount. The idea is if you have some amount of money, in this case is given, if you have $1,000 and single amount means that you only have this amount to invest once and you want to invest it for 4 years at 10% interest per year, how much are you going to end up as a future value at the end of 4 years? Well, you can do it year by year to see how it works. 1,000, you make 10% interest, you end up 1,100 to end of first year. Then you take this amount and you compound again. 1,100 times 1.10, this is how much you end up end of the second year. See the compounding process inside here. Then you take this amount and you compound again. Okay. Now there is a general formula that's easier to apply for any amount, any number of years, any interest rate. That's the general formula. Future value of any starting point is the present value, which is the sum, the amount you want to invest once, times 1 plus interest rate, and that's the power of n. Interest rate to be compounded under an n number of periods. Well, there is an appendix that we can use. This is just a piece of the appendix that you have at the end of your e-textbook. When you have, number of periods, always number of years is going to be on the column. N equals 4, interest rate 10%. That's the factor there, 1.464. Then you multiply this factor, multiply that by the original amount to be invested in 1,000 in our case. So you are going to end up at the end of 4 years with 1,464. Well, this table, you have actually bigger one with more values for interest rate and for years. And to locate this appendix, you'll go to the book content. This is your e-textbook. And you go the end here and the matter. And then you have there all appendixes here. And that's the first one that we are talking about right now, future value of $1. And that's the one that goes in 2 tables actually, because this is appendix A. It goes from interest 1 to 11% for up to 50 years, and then it continues to up to 30%. Let's make these tables bigger because they are pretty small, so you can see these numbers. Okay, so let's see, that's our appendix A, one amount to be invested. Suppose you have $10,000, one amount to invest for 10 years. So you're going to look here, 10 years, for interest rate at 6%. Okay, that's 6%, 10 years, and that's the factor. So then you are going to multiply this factor by the amount you want to invest. Let's say we said 10,000. So 10,000 times 1.791 is going to give you 17,910 at the end of 10 years. This is how it works. Future value of any amount. See, use this appendix, that's appendix A. And then we also have another concept now, present value. Present value. What is the present value of any amount to be received a number of years from now, when you take out an inflation of some amount, okay? Here, following the book example, you have what is the present value of $1,464 if you discounted to be received 4 years from now, and you discount for 10% interest rate, okay? Now you take out inflation, you discount it, so you are going to end up with less amount, okay? So here you have, that's going to be appendix B, present value of one sum. Again, a piece of it, you have it here in the PowerPoint. N equals 4, interest rate 10%, that's the discount factor is called, multiply 1464, and you are going to end up with 1,000, okay? So basically future value and present value are mirrored to one another. When you go into the future, you multiply your amounts because you add this 10% interest and you compound it every year. When you come from the future into the present, you end up with lower. You start future value 1464 and you take out this 10% inflation rate every year, so you end up with lower present value, okay? The bigger appendix here is appendix B, and it's starting right here, present value of $1, but you can apply it to any amount. So let's say, what is the present value of $10,000 discounted at 6% for 10 years? So then you do $10,000, that's my 10, let's see where they intersect, 10 years, 6% is here. So 10,000 times 0.558, the present value of 10,000 discounted at 6% for 10 years ends up being 5,580. Why? Because the discount rate is pretty high, 6%, and you take 6% every year plus the compounding process inside it, you end up with less money today. So next I'm going to work on a video with the applications of these two concepts, future value of one sum and present value of one sum.